Your power bill went up this year. Part of why traces to something you never plugged in. $16 a month for a typical home in one American state. That something is a data center, a building full of computers running artificial intelligence. And here's the one thing I want you to keep warm for the whole video. There are two true numbers in this story that point in opposite directions, and both sides are right.
Hold on, that's real money. This is Bella, and I pay that same bill. Where does a whole extra $16 a month even come from?
A data center draws power like a small city that never sleeps. I'm Erica. Take one of these buildings apart. Inside are tens of thousands of chips pulling a steady, enormous block of electricity around the clock, holidays included.
Think of it like the difference between a house and a factory landing on your street overnight. Chris here. Your house sips power. One of these campuses gulps it, and it does not turn the tap down at dinner time.
Look at where they sit. Right next to the high voltage lines and a substation the size of a stadium, because that's the only way to feed something this hungry.
So what does one thing you type actually cost? One typical query to a chatbot is about 0.3 watt-hours. The exact number is small, roughly what an LED bulb burns in a couple of minutes.
Wait, that's tiny. So why is everyone so worked up about the power?
Because one is nothing and a billion is a city. Watch what happens when I put the range on the board. Not every question is a quick one. A short question is a third of a watt-hour. A long one is a few. A heavy reasoning query, the kind that thinks before it answers, can run to tens of watt-hours. Same chatbot, 100 times the appetite.
And the good news nobody puts in the scary headlines. The exact number is that cost per query has fallen roughly tenfold since 2023, as the chips and the software got sharper.
Okay, the chat just pushed up the exact question I keep dodging. Someone asks, if one question is basically free, why does my bill know AI exists? Here's who this hits, and it's a fair question, so let me actually answer it. It's not the one question. It's 1,000 of these buildings, each one running millions of questions a second, all day. The tiny number multiplied by a planet.
So the tiny number and the terrifying number are the same number, seen from two distances. Now stand at the far distance. 0.3 watt-hours times the whole world.
There are two completely different power bills hiding inside artificial intelligence, and people mash them into one scary word. This whole episode lives on layer 5 of the AI stack, the hardware every message you send secretly runs through. The first bill is training. Building the model once. It's a mountain of electricity, thousands of chips grinding for weeks or months to create the thing. Huge, dramatic, and over when it's over.
Okay, so training is the big scary number I keep seeing quoted.
And that's exactly the trap. The second bill never ends. Every question every user asks is called inference, forever. It's a river that just keeps running.
The mountain and the forever river. Wait until you see which one your electric bill is actually made of. First, watch which one is bigger over time.
Once a model is popular, inference dwarfs training. Answering the questions burns more than 80% of the total. Let me put it on the board. The one big training run makes the headline. But run the arithmetic with me. 10 million people, each asking a handful of questions a day. That passes the entire training cost in, call it 2 days of answering. After that, it's all river.
And this is the number that stopped me cold. For years, everyone quoted 3 watt-hours a query. Check me on this, because I kept repeating it too.
Not quite anymore. That 3 was the 2023 estimate. The current read, from Epoch's analysis last year, is about a third of that for a typical query. The machine got more efficient while everyone kept quoting the old page.
So here's the reason it still doesn't save us. Efficiency per query fell tenfold. But usage went up far more than tenfold, so the total keeps climbing even as each piece.
Wait, cheaper per query makes it worse?
Worse for the total, yes. 10 times cheaper, 100 times the demand. The slice shrank and the pie exploded. That's the whole knot in one sentence.
Okay, I fold.
which is why the real number is a growth curve, not a snapshot. Erica, put the world on the board.
The energy watchdog everyone cites, the IEA, pegs data centers at about 415 terawatt-hours in 2024. That's roughly 1.5% of all the electricity on Earth. A terawatt-hour is a billion kilowatt-hours. That's the kind of unit that runs a country for a while, and by 2030 they project it roughly doubles, toward 945 terawatt-hours, near 3% of the world's power. Data centers growing about 4 times faster than electricity demand from everything else.
So walk with me on the human version of that. A country's worth of new power demand, arriving in a handful of years, all needing to land somewhere real. And somewhere real is somebody's town.
Before we keep going, one small favor that actually moves the needle. If this is landing for you, tap like, then subscribe and turn on the bell so you do not miss the rest. 2 taps, completely free, and it pushes this in front of more people who need it. A country's worth of new demand has to physically land somewhere, and Erica thinks the grid was never built for a neighbor like this. So let's have it out. What makes a data center different from any other big customer on the wire?
Everything about the shape of it. A factory ramps up and down with shifts. A town breathes, high at dinner, low at 3 in the morning. A data center is a flat wall of demand, 90+% every single hour. The grid has to be sized for that constant peak, and you can't build a little. You build the whole substation and the whole new line before the first server even switches on.
And that's the part I sit with, because I grew up in a town exactly like this. Here's who this hits first, not the company. The family 2 miles from the new substation, who wake up to a hum that wasn't there last year and a rezoning notice they never asked for.
Erica, push back on exactly that, head on. Bella says the neighbor pays first. Is that fair, or is that just the price of the internet everyone uses?
Here's the honest read, and it's not a dodge. Yes, everyone benefits from the cloud. But the electricity bill and the noise and the rezoning are local, and the benefit is global. That's a real mismatch, not a talking point.
Walk with me 1 town over because I've watched this meeting happen. A company shows up with a jobs promise and a tax
Abatement. A tax abatement.
That, the council says yes. Then the neighbors learn the jobs are a few dozen. The power and the noise are enormous, and the transparency was
thin. It usually is thin.
Thin is generous, and I want to be careful here because this is a system story, not a villain story. No party did this. The rules just never imagined a customer this big landing this fast.
Let me land that for everyone watching. The technology isn't the neighbor problem, the speed is. A decade of grid build-out is being asked for in about 2 years, and the rulebook is a step behind.
And there's a number under the anger. In Northern Virginia, they call it Data Center Alley. The counties around Loudoun host more than 300 of these buildings, the densest cluster on Earth. A big slice of the whole internet physically runs through.
Wait, which number though? Because I've seen 3 different traffic figures quoted and they can't all be right.
Good catch, and honestly that's my job in the middle seat. 1 at a time. Erica, the count you'd stand behind, 1 sentence. Then Bella, the human line.
The count I'd stand behind, over 300 data centers in those counties, a very large share of global internet traffic. That one's solid.
And the human line. $16 a month is my whole month of Sunday idly. Except I never ordered this and I can't cancel it.
So here's where we land it, as a scoreboard, because both sides won something real. The strain gets the grid. It's a genuine country-scale load that has to be built now, and pretending otherwise is a lie. The neighbor gets the fairness. The people nearest the wire pay first for something the whole planet uses. 2 true things, sitting right next to each other.
And the family 2 miles from the substation? They never actually got a vote. They got a bigger bill instead. That's the answer to the vote they never got. When a data center needs the grid rebuilt, the cost doesn't just float away. It shows up in a rate case, and rate cases land on everybody's meter.
So let's trace the actual dollars, because this is where it stops being abstract. The place it flows through is something called the capacity market, the pool that pays to keep enough power ready for the worst day.
Step 1. Follow the wire to your meter. When new demand shows up, that capacity gets more expensive for everyone on the grid, not just the new guy.
And the PJM jump is on the record. In the big regional grid that covers the Mid-Atlantic, data centers drove about 63% of the price increase in the last capacity auction. Not a slice, the main event.
Here's who that becomes. Picture Diane, a retired postal carrier 2 counties from the alley. She's on a fixed income and has never once opened a chatbot. Chris, show her the receipt.
Around Washington, one utility's bills went up about $21 a month starting in mid-2025. Let me line it out. 10 of that 21 is the capacity spike, and the grid's own consumer advocates trace that spike mostly to data center demand.
So the honest read is that roughly half of Diane's increase is the machine she never touched. About $10 a month.
$10. On a fixed income, that's a prescription she skips some months.
Now, remember the number I told you to hold from the top. Here's the loop closing. The data center makes the money in one place, and the wire it leans on is paid for by everyone. Which raises the obvious question.
Chris, you keep chewing on the thing everyone's actually thinking. Just ask it.
Fine. If the data center makes the money, why is the grandmother down the road paying for the wires?
For a century, the rules said big new customers and small old customers share the grid's cost. That was fine when the big customer was a factory. It breaks when one customer needs the whole system rebuilt. And regulators are finally noticing. Virginia just approved a new rate class. The largest users, the data centers over 25 megawatts, get pushed to carry far more of the grid costs they create. That starts in 2027. It's the first real attempt to move the bill back onto the building that caused it.
Honestly, I had this backwards. I figured the companies already paid their own way. They mostly didn't. Erica had the regs, I didn't.
For now, until those rules actually bite, the answer to the grandmother question is blunt. You pay for the grid whether or not you ever use AI. That's the part that stings, and it's true.
So put a real number on your own life. If you're near a build-out, some of your bill is already a data center. $10 a month, $30, depends where you live. Two true numbers pointing opposite ways. That's where we started. And now we can name them. The per query cost keeps dropping. The total keeps climbing. 2 arrows, opposite directions, both measured.
So hold both, don't pick.
And the efficiency side is not a talking point. Newer chips do more math per watt. The forever river got narrower per drop, genuinely. Take that seriously before you doom scroll.
Right, and there's a real supply story too, isn't there? Companies signing deals for clean power?
There is, and I want to hand that to someone who knows these grid filings inside out, not us. Let me bring in Amara Okafor, who reads this power grid like a map. Amara, can you hear us?
Hold on, before you frame it as a rescue, the question isn't whether AI can be powered cleanly, it's whether we build the clean power fast enough to keep up with the demand. 2 different fights, and people lose the second one.
So are the nuclear and renewable deals real, or are they press releases?
Real and not enough on their own. Companies really are signing for nuclear and for solar and wind at serious scale. 9 times out of 10 the megawatts are genuine, but new clean supply takes years to build and the demand is landing in months.
So who actually wins the 2-curve race?
Depends which race. Per query, efficiency wins easily. Total power on the grid, demand wins for now. The machine is getting leaner and the world is buying way more of
it. So efficiency wins the sprint, demand wins the marathon. Think of it like a car that sips less gas every year while the driveway keeps filling with more cars. The tank still drains faster. That's the line I'm keeping.
And for a family near a build-out, does any of that efficiency reach their bills soon?
Which family, though? Near a new build or on an old, stable grid? Two different answers. Near a new build, honestly, not for a few years. The wires have to be paid for first. That's the short version.
That's the piece the brochures skip. The clean deals are real. The relief is just slow. That gap is the whole story.
And this is only half the invoice. We spent the whole hour on watts, on the forever river of power, the water these machines drink, the land they eat, the carbon. A separate ledger. That's the entire next episode.
One thing before we go. Check your own bill. If a build-out is near you, some of that number is already AI. Now you know the name for it.
One hour, one picture. AI's power bill is a tiny number times the whole planet, and the wire it runs on is paid for by everyone.
Right tool, right bill.
Next time we flip to the other half of the invoice. The water these machines drink to stay cool and the land they eat. Same buildings, a completely different cost.
Here's the move tonight. Pull up your last power bill and find the supply and capacity lines. You can't fix what you can't see, and now you can see it.
My favorite fact from today is still that the tiny number and the terrifying number are the exact same number, just seen from two distances.
If this made the machine behind your chat window a little less invisible, subscribe and follow the series. We're building it one layer at a time, and the water episode is the other half of this exact story, and the one only you can answer. Would you take a data center in your town for the jobs and the tax money if you knew it might add $10 a month to your power bill? Tell us in the comments. Thanks for watching, everyone. Go read your meter tonight and bring your questions to the water episode.
Emma, that was a clinic. I took notes. That does not usually happen. This is Professor Erica. Thanks for watching and signing off.